Now in this video, I'm just basically gonna talk about how do we find like a vector equation, a parametric equation, and a symmetric equation. So let's say we have points. Let's say we have points A and B. So let's say maybe A is given the coordinates 1, 3, 5, and remember that the coordinates are given by x, y, z, right? X, y, z. And let's say that we have a point B given by 4, 1, and 3. So our vector is passing through these 2 points. So then we need to get a vector that will be parallel to those 2 points. So V will be given by vector AB. Then this will be denoted by 4 minus 1, which is 3, and 1 minus 3, that's minus 2, and 3 minus 5, that's minus 2. So that will be your V. And from that, remember in the last video I showed you like R is equals to R naught plus T multiplied by V. So here, R naught, you just pick any coordinate from this. So I'm just going to pick A. So I have 1, 3, and 5. Plus T multiplied by this one, which is just going to be 3 minus 2 and minus 2. And this will be your vector equation. This is known as like the vector equation. Vector equation. And from this, if you have the vector equation, we can get the parametric equations. Parametric equations is given by x equals x naught plus at, and y will be given by y naught plus bt, and z will be given by z naught plus ct, where this is a, b, and c. Where this is a, b, and c. So now that means that here we can have, this one will be x naught, y naught, and z naught. So the equation will be given by x equals 1 plus 3t, and y will be given by 3 minus 2t, and z will be given by 5 minus 2t. So this ones will be your parametric equations. Your parametric equations. And from that we can solve for t in any case, and we know that t is equals to t is equals to t. So if we solve for t here, then that means that we'll have x minus 1 divided by 3, and if we solve for t here, we'll get that y it's equals to y minus 3 over minus 2, and if we solve for t here, that will be z minus 5 over minus 2. So this equation here is known as the symmetric equations. Symmetric equations. So in short, you only need like 2 points to find the equation of a line, to find the equation vector, or the equation of a line passing through some certain points on that vector. You only need 2 equations. So in summary, we know that the symmetric equation will be x minus x naught over a, y minus y naught over b, and z minus z naught over c. That's given that v will be denoted by a, b, and c. And that is denoted by like the initial coordinate or some point along that vector will be given by x naught, y naught, and z naught. And thus the parametric equations will be given in this form, and the vector equation will be given by r is equals to r naught plus tv. So now that you have like a vector equation of this, you can find any points along that vector. Let's say, suppose that we want to find, let me rewrite that. Remember I said r is equals to 1, 3, 5 plus t into 3 minus 2 minus 2. So now, let's say I want to find a coordinate on that vector. Let's say C. I want to find C, a point C on that vector. So now, let's say maybe t is equals to 1. If t is equals to 1, then we'll get a point on that vector, 1 plus 3. Since 1 times 3 is 3, and you add it with 1, then you're going to get 4. And you say 1 multiplied by minus 2, you're going to have minus 2, and you add it with 3, then you're going to have 1. And then you say 1 multiplied by minus 2, then you get minus 2, and then you add it with 5, you're going to have 3, which is just this point here. So basically you can get any points there. So if t equals 2, you can have a point there. So you're just going to substitute 2. You multiply this once with 2, and then you sum this 2. And then if t equals 2, let's say we have point D, and that point will be denoted by 2 by 3, it's 6, 6 plus 1, that's 7. And 2 by minus 2, that's minus 4. And 3 plus minus 4, that's going to be minus 1. Minus 1. And then it's minus 4. Then you add it with 5, then you're going to have 1. So that will be like how you use that equation. So this is the vector equation. This is the parametric equations, and this one's are the symmetric equations. And you can find the parametric equation if you have the symmetric equation, and you can find also the vector equation using either one of these two. So that's how you'll solve the things.